Vector, so we have scalars, right? We have scalars, these are numbers, 1 2 3 4. So they have only magnitude, no direction. These only say till n whatever it is. So these are numbers, these are scalars. Okay, they only represent magnitude. What is the magnitude within them? They represent that. But for a force we need a magnitude, that is, say for example 5 Newton force, plus the direction in which the force is applied, right? Which direction the force is applied. So that direction is important, and these things cannot be used to represent a simple number. Will just give the magnitude. So the other part is brought in by the vector. So vector is nothing but a collection of scalars. Okay, it is a collection of scalars. It is used to, it has a magnitude plus direction, in which direction this is happening. So this direction is very important, that differentiated from a scalar. So it has a magnitude plus direction. So geometrically, as I mentioned, this is just like a line segment. So it will have some origin. So it's generally the origin is the origin, and from there it will have some length and the direction in which it is there in the space represented. Okay, so this is your vector, and generally it's represented with an arrow on top of a symbol. Say this is a V and there's arrow. Arrow means it has a direction. And generally when we do operations, when we say vectors, and then we don't write arrow always, but it is represented by capital letters. That's the convention for understanding. And when we say it's a collection of scalars, so we represent a vector as a column vector. Okay, so column vectors are always represented as a column. Column means, say for example, if I have vector V, this is represented as V1, V2, V3 in this format, not in this format. If I say V is equal to V1, V2, V3, this is row format. This is not the format. This is row format. This is not. This is the one. So always that's the convention we follow. That's the convention we'll be following. A vector is represented as a column vector. These numbers V1, V2, V3 are scalars, but a collection of them. And when we define more terms, you will get more and more clear from where the direction etc. is coming in this, and what is the basis of these directions. Okay, so this is represented as a column vector, not a row vector. So if I represent it like this, so this is nothing but the same thing. When I move the column to the row format, this is nothing but vector transpose. Okay, we say this is a V transpose. So this is V. So this V transpose is there. This is transpose means the column is converted into a row. So this whole thing is made, this vertical thing is made horizontal. Okay, so this 90-degree flip happened. So this is a V transpose. Column is moved to a row. Simple. So I hope so. This one more term is clear. So we understood what is a transpose. We understood what is a vector, and then what is a vector transpose.